February 20th, 1942. 23,000 feet above the Timor Sea, somewhere between Java and Australia. Lieutenant Robert "Bobby" Malone looked in his rearview mirror and saw death coming for him. 17 Japanese Zeros, arranged in 3 staggered formations, were closing on his tail at a speed that should have been impossible for him to escape. His P-40 Warhawk was already at full throttle, the Allison engine screaming at the edge of its tolerance, and still the Zeros were gaining. At this rate, they would be in firing range within 2 minutes. Bobby had been separated from his squadron during a chaotic engagement over the Japanese invasion fleet. His wingman was gone, shot down or escaped, Bobby did not know. His radio was dead, hit by a stray round that had also punched a hole in his left wing. He was alone, damaged, low on ammunition, and facing odds that no pilot could survive. The mathematics of aerial combat were brutal and simple. The Zero was faster than the P-40 at this altitude. The Zero could climb better. The Zero could turn tighter. Bobby had exactly one advantage. In a dive, the heavier P-40 could build speed that the lightly built Zero could not match. But diving meant losing altitude, and he was already too low. Another dive would put him at the surface of the ocean with nowhere left to go. Unless... Bobby reached down and pulled a lever that did not appear in any P-40 manual, a lever connected to a modification that the other pilots had laughed at for weeks, a modification built from a coffee can lid, some baling wire, and the desperate ingenuity of a man who refused to accept the limitations of his aircraft. The engine note changed. The airspeed indicator began to climb, and Bobby Malone, the mechanic's son from Oklahoma, who had been told his modification was worthless, felt his Warhawk surge forward with power that the Allison engine was never designed to produce. The Zeros fell behind. Not by much, not at first, but enough. Enough to buy time. Enough to reach the clouds on the horizon. Enough to survive. And as he pulled away from 17 enemy fighters that should have killed him, Bobby allowed himself a single thought. The can lid worked. If you are watching from anywhere in the world, take a moment to like this video and subscribe to the channel. We bring you stories from World War II that reveal what happens when ordinary people refuse to accept impossible situations, when one pilot's unconventional thinking means the difference between life and death. Tell us in the comments where you are watching from today. These stories survive because we remember them together. Robert Earl Malone was born in 1918 in the oil town of Tulsa, Oklahoma, in a small house that shook every time the nearby derricks pumped another barrel of black gold from the earth. His father, William Malone, was a mechanic who worked on the engines that powered the oil industry, the pumps and generators and trucks that kept the wells producing and the money flowing to the men who owned them. The Tulsa of Bobby's childhood was a boomtown, wild and chaotic, and full of opportunity for those who could work with their hands. The oil fields stretched for miles in every direction, a forest of wooden derricks and iron pipes, and the men who serviced those fields were as important as the roughnecks who drilled the wells. The Malone family was not wealthy, despite living in the heart of America's oil boom. William worked long hours for modest wages, coming home each night with grease under his fingernails and the smell of petroleum in his clothes. But he had one gift that no amount of money could buy. He understood machines the way some men understood music or mathematics. He could listen to an engine and diagnose its problems by sound alone. He could look at a mechanism and see how to make it work better, faster, more efficiently. Bobby grew up in his father's workshop, surrounded by the smell of motor oil and the sound of metal against metal, learning the language of engines before he learned to read properly. By the time he was 6, he could identify engine parts by sight, pistons and valves and crankshafts, carburetors and distributors and generators. By 10, he could change the oil in a truck without supervision, his small hands finding their way into spaces that grown men could not reach. By 14, he was helping his father rebuild engines that other mechanics had given up on, finding solutions to problems that seemed unsolvable, resurrecting machines that everyone else had declared dead. His father taught him the philosophy that would guide his entire life. Every machine was a compromise. Engineers made choices about weight and power and durability, and those choices created limitations. But limitations were not laws of nature. They were decisions, and decisions could be changed. The most important lesson came when Bobby was 16. His father had acquired a broken-down Ford Model T that a customer had abandoned, and together they set about restoring it. The engine was weak, barely able to climb the hills outside Tulsa, and Bobby asked if they could make it more powerful. His father smiled and opened the engine compartment. He pointed to the carburetor, the device that mixed air and fuel for combustion, and explained how it worked. The factory carburetor was designed for reliability, not performance. It delivered a safe, consistent mixture that would keep the engine running for years without problems. But if you adjusted the mixture, more fuel, more air, you could extract more power from the same engine. The trade-off was increased wear and higher fuel consumption. The factory had decided that reliability was more important than power. Bobby and his father could make a different decision. They modified the carburetor that afternoon, using nothing but hand tools and intuition. When they started the engine, the difference was immediately apparent. The Model T that had struggled up hills now climbed them with ease. The power was there all along, hidden behind the factory's conservative choices. Bobby never forgot that lesson. He never forgot that the engineers who designed machines made decisions based on their priorities that might be different from the priorities of the people who actually used those machines. And those decisions could be changed by someone who understood the trade-offs, someone who was willing to accept different consequences in exchange for different performance. When he graduated high school in 1936, Bobby did not go to college. His family could not afford it, and besides, he had already learned more about engines in his father's workshop than any classroom could teach. Instead, he took a job at a local aviation company, working as a mechanic on the small planes that crisscrossed Oklahoma, carrying mail and passengers and cargo. He learned to work on aircraft engines the same way he had learned to work on automobiles, by listening, observing, and experimenting. And in 1940, when war clouds gathered over Europe and the Army Air Corps began expanding, Bobby enlisted as a pilot. His mechanical knowledge gave him an advantage in flight training that no amount of natural talent could match. He understood his aircraft from the inside out, knew exactly what the engine was doing at every moment, could feel problems developing before the instruments showed them. He graduated near the top of his class and was assigned to a pursuit squadron flying P-40 Warhawks, the same aircraft that would carry him into combat over the Pacific. The Curtiss P-40 Warhawk was one of the most produced American fighters of the early war years, and also one of the most criticized by the men who had to fly it. Its problems were well known and frequently discussed, the subject of bitter complaints in every mess hall and ready room where P-40 pilots gathered. The Allison V-1710 engine that powered it was designed for low altitudes and lost significant power above 15,000 feet, the result of engineering decisions made for commercial applications that had never anticipated high-altitude combat. At high altitude, where most air combat took place, the P-40 was slower than nearly every enemy fighter it faced. The Japanese Zero, in particular, could outrun, outclimb, and outturn the Warhawk at virtually any altitude. Pilots who flew the P-40 developed tactics to compensate for its weaknesses. They avoided turning fights with Zeros, using diving attacks and hit-and-run passes instead. They tried to stay below 15,000 feet, where the Allison engine performed better. They accepted that they were flying a second-rate fighter and did their best to survive with it. But Bobby Malone saw things differently. He looked at the P-40's limitations and saw decisions, the same kind of decisions his father had shown him in the Model T all those years ago. The factory had made choices about engine tuning, about fuel mixture, about the balance between performance and longevity. Those choices could be changed. He began experimenting in December 1941, after the attack on Pearl Harbor threw the Pacific into chaos and made it clear that the war would be long and brutal. His squadron was stationed in the Dutch East Indies, defending the oil fields and ports that Japan was determined to capture and that the Allied nations were determined to hold. They were outnumbered, outgunned, and flying aircraft that everyone acknowledged were inferior to the enemy's. It was a recipe for disaster, and everyone knew it. The experiment started small, tentative, almost secretive. Bobby adjusted his fuel mixture. Running richer than the manual specified, extracting a few extra miles per hour at the cost of increased fuel consumption. He experimented with his propeller pitch, finding settings that worked better than the factory recommendations for his specific conditions. He tinkered with his supercharger, the device that forced more air into the engine at high altitudes. The other pilots noticed his modifications and reacted with skepticism bordering on hostility. Bobby was not an engineer. He was not authorized to modify military equipment. If something went wrong, if his engine failed in combat because of his unauthorized changes, he would be responsible for the loss of a valuable aircraft. The squadron commander, Captain Harold Price, called Bobby into his tent and warned him to stop. The P-40 was what it was. Their job was to fly it as designed, not to play mechanic with government property. Bobby agreed to stop, and then he kept experimenting anyway, working at night, keeping his modifications as subtle as possible. The breakthrough came in early February 1942, when Bobby discovered something that the Allison engineers had apparently overlooked. The supercharger was the key. A supercharger worked by compressing air before it entered the engine, allowing more fuel to be burned and more power to be produced. The Allison engine in the P-40 had a single-speed supercharger that was optimized for medium altitudes, a compromise that left the engine underpowered both at sea level and at high altitude. Bobby had been studying the supercharger for weeks, lying awake at night thinking about airflow and pressure and the basic physics that governed engine performance, trying to understand why the P-40 performed so poorly above 15,000 feet. The answer, when it finally came to him, was airflow. At high altitude, where the air was thin, the supercharger could not compress enough of it to maintain engine power. The engine starved for oxygen, just like a man climbing a mountain, and the aircraft slowed as a result. The solution, Bobby realized, was to increase the pressure inside the supercharger inlet, to pack more air into the system before compression began, to give the engine the oxygen it needed even when the atmosphere was too thin to provide it naturally. This was not a new idea. Engineers had experimented with various methods of ram air intake, using the aircraft's forward motion to force additional air into the engine. But the P-40's intake system was not designed for this. The airflow path from the nose scoop to the supercharger was inefficient, with turns and baffles that dissipated the ram effect. The factory had prioritized cooling and debris rejection over raw performance. Bobby's modification was elegantly simple. He fashioned a small ram air scoop from the lid of a coffee can, shaping the metal into a curved surface that would capture air and direct it into the supercharger inlet. He mounted it using baling wire and aluminum strips, positioning it precisely to maximize airflow without creating excessive drag. The modification looked ridiculous. There was no other word for it. A coffee can lid wired to the engine cowling of a military fighter, jutting out like some kind of metal tumor or a child's art project gone wrong. The other pilots laughed when they saw it. They called it Bobby's nose job and asked if he was trying to make the ugliest plane in the Pacific. They wondered aloud if he had lost his mind, if the stress of combat had finally cracked him. Bobby ignored them. He had heard similar laughter in his father's workshop, when oil field workers brought in engines and scoffed at the unconventional repairs William suggested. He took the modified P-40 up for a test flight and pushed it to high altitude. The results were remarkable. At 20,000 feet, where the unmodified P-40 normally lost significant power, Bobby's engine was producing thrust that felt almost normal. The airspeed indicator showed nearly 15 miles per hour, faster than his previous flights at the same altitude. The ram scoop was working, forcing additional air into the starved supercharger and restoring the power that thin air normally stole. There were trade-offs, of course. The modification created additional drag at low altitudes, actually reducing performance below 10,000 feet. The increased air pressure put additional stress on the supercharger, which would probably reduce its lifespan. And the jury-rigged mounting was not aerodynamic, creating turbulence that affected handling in certain conditions. But at high altitude, where the Zero had its greatest advantage, Bobby's modification gave the P-40 a fighting chance. He kept the modification secret, working at night to install and remove the ram scoop, depending on the expected mission profile. The other pilots assumed he had abandoned his experiments. Captain Price stopped watching him. and Bobby waited for the moment when his modification would be tested in actual combat. That moment came on February 20th, 1942. The mission was supposed to be a routine patrol over the Timor Sea, looking for Japanese ships approaching the Dutch East Indies. Bobby's squadron had been flying these patrols for weeks, rarely encountering enemy aircraft, mostly watching the endless blue of the ocean pass beneath their wings while trying to stay alert in the tropical heat that seeped into the cockpit despite the altitude. But on February 20th, they found exactly what they were looking for, and far more than they could handle. The Japanese fleet appeared on the horizon just after noon, a dark smear against the water that resolved into individual ships as they drew closer. Transports heavy with troops and equipment, destroyers cutting protective circles through the waves, cruisers with their guns trained on the sky, and above them, circling like hawks, was the largest formation of Japanese fighters Bobby had ever seen. The squadron commander ordered an attack on the transports, knowing it was probably suicide, but understanding that someone had to try to stop the invasion. The P-40s dove toward the fleet, their guns blazing, trying to damage as many ships as possible before the inevitable Japanese response. The response was swift and overwhelming. Zeros descended on the American formation from every direction, their superior numbers and performance turning the attack into a massacre. Bobby saw two of his squadron mates go down in the first 30 seconds, their P-40s trailing smoke and flame as they spiraled toward the ocean. He fired at a Zero that crossed his path, saw hits on the enemy's wing, then broke away as another Zero appeared in his mirror. The next few minutes were chaos, turning, diving, climbing, shooting, a blur of sky and ocean and enemy aircraft that seemed to be everywhere at once. When the chaos cleared, Bobby found himself alone. He had been separated from the surviving members of his squadron, pushed away from the battle by the weight of Japanese numbers. His radio was dead, hit by a round that had also damaged his left wing. His ammunition was nearly exhausted, and behind him, climbing to match his altitude, were 17 Japanese Zeros. They had spotted him. They were coming. Bobby checked his altitude, 23,000 feet, high enough that his unmodified P-40 would be hopelessly outclassed, high enough that the Zeros could catch him easily, kill him at their leisure. But Bobby's P-40 was not unmodified. He had installed the ram scoop that morning, anticipating a high-altitude mission. The coffee can lid was still wired to his engine cowling, still capturing air and forcing it into his supercharger. He had not told anyone about the modification. No one knew what his aircraft could actually do. Bobby pushed the throttle forward and felt the engine respond. The ram scoop was working, feeding the Allison engine the air it needed to produce power at altitude. His airspeed began to climb, not dramatically, not fast enough to pull away immediately, but faster than it should have been, faster than the Zeros expected. The gap between Bobby and his pursuers stabilized. They were not gaining anymore. In fact, as Bobby watched his instruments, he realized they were actually falling behind. Not by much, a few hundred yards over the first minute, but the trend was clear. The Zero pilots pushed their engines harder, trying to close the distance. Bobby could see them in his mirror. Could imagine their confusion as the P-40 they were chasing refused to slow down, refused to behave like every other P-40 they had ever encountered. He flew north, toward a bank of clouds on the horizon that represented his only hope of survival. The clouds meant safety, cover where the Zeros could not follow, where he could disappear into the white mist and find his way home by dead reckoning and prayer. They were 10 miles away when he first spotted them, then 8, then 5. Each mile felt like an hour. Each glance in the mirror showed the Zeros still there, still trying, still falling slightly behind but not giving up. The Zeros gave up the chase at the edge of the cloud bank, peeling away one by one as they finally realized they could not catch him. Bobby counted them as they turned. 17 Zeros that should have killed him, defeated by a coffee can lid and the lessons his father had taught him in an Oklahoma workshop. He entered the clouds and let out a breath he had not realized he was holding. Bobby landed at his airfield 3 hours later, running on fumes, his P-40 scarred by bullet holes that told the story of the morning's battle, but still flying, still carrying him home. He was the last member of his squadron to return, and one of only 4 survivors from a mission that had cost the lives of 8 good men. The ground crew surrounded his aircraft as he climbed from the cockpit, their faces showing the relief of men who had expected to prepare another memorial service, who had already begun to assume that Bobby Malone would not be coming back. Captain Price pushed through the crowd and demanded to know how Bobby had survived. Bobby considered lying. He could have said he got lucky, that the Zeros gave up for some unknown reason, that he found a cloud bank at exactly the right moment. The truth, that he had modified his aircraft against direct orders and used the modification to escape, would mean a court-martial at worst, a severe reprimand at best. But Bobby was tired of hiding. He had just survived an encounter that should have killed him, and he had survived because of something he built. The other pilots deserved to know. He led Captain Price to the engine cowling and pointed to the coffee can lid, still wired in place, still covered with the grime of combat. "This is why I'm alive," Bobby said. "Ram air intake forces more air into the supercharger at high altitude, gives the engine maybe 10% more power above 20,000 feet. Price stared at the modification, his expression cycling through confusion, anger, and something that might have been respect. "You modified a military aircraft without authorization. You disobeyed a direct order. You could have gotten yourself killed." "I could have gotten killed without the modification too, sir. At least this way I had a chance." Price was quiet for a long moment. Then he did something that surprised everyone watching. He called for the squadron's chief mechanic and ordered him to study Bobby's modification. Over the next week, the mechanic examined the ram scoop with growing fascination, measured its effects on engine performance, using whatever instruments were available, and compiled a report that was sent up the chain of command to engineers who could not believe what they were reading. The modification was not perfect. It increased wear on the supercharger, it reduced low-altitude performance, it was ugly as sin and probably violated a dozen regulations, but it worked. At high altitude, it gave the P-40 a meaningful improvement in speed and power that could mean the difference between life and death. Bobby was not court-martialed. He was not even formally reprimanded. Instead, he was quietly transferred to an engineering support unit where his talents could be applied to modifying aircraft rather than flying them. It was not the assignment he wanted. He was a pilot, not a mechanic, but it was better than prison. He spent the rest of the war working on modifications like the one he had invented. Some were adopted, incorporated into official upgrade packages that improved aircraft performance across the Pacific theater. Others remained experiments, promising ideas that never quite worked well enough for widespread use. The ram scoop itself was never officially adopted. The engineering complications outweighed the benefits for most situations, but the principle behind it influenced later designs. Bobby's insight about forced air induction contributed to the development of improved supercharger systems that would eventually make high-altitude performance a standard feature of American fighters. Bobby Malone returned to Oklahoma in 1946, discharged with honors but no fanfare, just another veteran coming home to a country that had changed while he was away. He took over his father's workshop after the old man retired, building a business that serviced the oil field equipment that still dominated the Tulsa economy. The skills that had kept him alive at 23,000 feet now kept the pumps running and the trucks moving, a different kind of essential work that suited him just fine. He married a woman named Sarah, who had waited for him through the war years, writing letters that arrived months late, and worrying through silences that stretched for seasons. Together they raised 4 children in a house not far from where Bobby had grown up, a house with a workshop in the back, just like the one where William had taught Bobby everything he knew. The workshop became a family tradition, with each of the children spending time learning the skills that Bobby's father had taught him, and that he now passed on to the next generation. Bobby rarely spoke about the war. When his children asked about his service, he told them only that he had been a pilot in the Pacific, that he had survived some difficult situations, that he had been lucky. The 17 Zeros, the coffee can lid, the desperate flight across the Timor Sea. These stories remained private, shared only with Sarah in quiet moments when the memories surfaced. But the lesson of the ram scoop stayed with him. Every machine was a compromise, every limitation was a decision, and decisions could be changed by someone who understood the trade-offs. He applied this principle to everything he touched, Oil field pumps that were rated for certain pressures. Bobby found ways to exceed those ratings safely when the job required it. Truck engines that were supposed to last a certain number of miles. Bobby made them last longer while also running stronger. Equipment that other mechanics declared beyond repair. Bobby found the hidden potential that the factory had left on the table. His reputation grew throughout the Oklahoma oil industry, spreading by word of mouth from one company to another, from one drilling site to the next. People brought him problems that no one else could solve, engines that other mechanics declared beyond repair, equipment that seemed destined for the scrap heap, and more often than not, Bobby found solutions that seemed obvious in retrospect, but that no one else had imagined. Solutions that came from seeing machines as his father had taught him to see them, as collections of decisions that could be changed. In 1987, a historian researching P-40 modifications during the Pacific War tracked Bobby down at his workshop in Tulsa. The historian had found references to unauthorized aircraft modifications in military archives and was trying to understand what had actually happened in the chaotic early months of the war. Bobby agreed to an interview, his first public discussion of the events that had shaped his life. He was 69 years old, his hands still strong from decades of work, his mind still sharp despite the years. He explained the modification in detail, describing the problem he had identified, the solution he had improvised, the combat that had tested it. He showed the historian a photograph of his P-40 from 1942, the coffee can lid clearly visible on the engine cowling, looking exactly as ridiculous as it had looked 45 years earlier. At the end of the interview, the historian asked the question that everyone eventually asked: how did it feel to outrun 17 Japanese Zeros with a modification made from a coffee can lid? Bobby was quiet for a moment, remembering the terror and exhilaration of that February afternoon, the endless minutes of watching his mirror and wondering if the Zeros would catch him, the relief when they finally turned away and the clouds swallowed him into safety. "It felt like my father was there with me," he said finally. "Everything I knew about engines, about machines, about the hidden potential that factory settings leave untapped. He taught me all of that. When I built that ram scoop, I was using his lessons. When I outran those Zeros, he was flying with me." He paused, his eyes distant. "They called my modification stupid. They said a coffee can lid could not improve a military fighter. They laughed at me for even trying. But I knew something they did not know, something my father taught me in a workshop in Tulsa when I was just a kid. Every machine is a compromise. Every limitation is a decision. And if you understand the trade-offs, you can make different decisions." Bobby died in 1999, at the age of 81, working on an engine that a customer had said was beyond repair, a fitting end for a man who had spent his life proving that nothing was truly beyond repair if you understood how it worked. He collapsed in his workshop, surrounded by the tools he had used his entire life, doing the work he had loved since childhood. His children found him there the next morning, his hands still holding a wrench, his face peaceful. They buried him next to his father in a cemetery overlooking the Tulsa skyline, the oil derricks still pumping in the distance, the smell of petroleum still hanging in the Oklahoma air. His grandchildren inherited the workshop, and some of them continued the tradition, learning the skills that had passed from William to Bobby, and now to another generation. The tools that Bobby had used were still there, arranged on the walls exactly as he had left them, ready for hands that understood their purpose. The coffee can lid from his P-40 was never recovered, lost somewhere in the chaos of the Pacific War, destroyed or discarded or simply forgotten in the retreat that followed the fall of Java. But the principle it represented lived on in everyone Bobby had taught, in every engine he had improved, in every limitation he had refused to accept, and in the story that his family told, passed down from generation to generation, of a young pilot who outran 17 Zeros with nothing but a piece of scrap metal and the lessons of an Oklahoma mechanic. They had mocked his can-lid engine modification. They had called it stupid, ridiculous, the desperate improvisation of a man who did not understand how aircraft engines worked. And then they had watched him outrun 17 Japanese Zeros in a single dogfight, escaping certain death with nothing but a coffee can lid and the lessons of an Oklahoma mechanic who had taught his son that every machine is a compromise, every limitation is a decision, and every decision can be changed by someone willing to see what others refuse to imagine. If this story moved you, take a moment to like this video and subscribe to the channel. Share in the comments what touched you most, and tell us where you are watching from today. These stories survive when we remember them together, and together we ensure that the ingenuity of ordinary soldiers who saw what others missed is never forgotten, never lost to the passage of time. The men who laughed at Bobby Malone were not fools. They were professional soldiers following professional procedures, maintaining military equipment, according to specifications that had been developed by trained engineers. Their caution was reasonable and appropriate. But Bobby understood something they did not, something his father had taught him in a workshop in Oklahoma, something about compromise and limitation, and the hidden potential that conservative designs leave unexplored. He understood that the men who designed engines made choices, and those choices could be questioned by someone who understood the consequences. Every machine is a compromise, every limitation is a decision, and decisions can be changed by someone who understands the trade-offs and is willing to accept different consequences in exchange for different performance. That is what Bobby Malone proved at 23,000 feet above the Timor Sea, with 17 enemy fighters on his tail and nothing between him and death but a coffee can lid. That is what we should remember today, that the people who see what others miss, who question what others accept, who find solutions in the places where everyone else sees only limitations, are the ones who change the world. And sometimes they save their own lives in the process.